In this next series for image manipulation with Python series of mine, I would like uh, to take a look at using thresholds. Now, suppose you have an image where you would like to distinct between foreground and background. So in this case, threshold and global threshold will come to help. So suppose I have a sphere or some other image and I would like to detach it from the background by using some threshold, which we'll find with the help of Python. Now, I would like to inform you that for this video, I will be using scikit-image library, and I will be using two filters from it. First, I will be using scikit-image filters. I will use this part of scikit-image, and I will use scikit-image colors module. From here, from scikit-image filters, I will be using optimized global threshold, which we will name Otsu threshold. And from scikit-image colors, I will be using RGB to gray. Now we can start the implementation. So let's begin. Now from scikit-image.filters, I'm importing threshold Otsu, which will be our global threshold finding algorithm. Then I am importing from scikit-image colors module RGB to gray. So then I will be using my image of this cat. Now I would like to turn it into a grayscale image. So let us name it cat grayscale and RGB to gray on my image that I have already loaded. If you don't know how to load, please look at my previous series. Now I will be finding the threshold here. So let's find it with the help of Otsu threshold Otsu function. As an input, it will be taking our grayscale image. Now this will find the necessary value instead of us guessing what type of threshold to give to our image. And I want to know that this is not the only algorithm for finding a threshold. This one is just for finding a global threshold value, let's say. So now I will apply this threshold with the help of cat grayscale being greater than or equal to our threshold. So the only thing left for us to do is to just show this image. And I will be using gray as our color map. Let's show this image. Now, here might be one problem. I might have imported it in a wrong manner. Yes, that's it. Now, this is how global threshold works. And as you can see, well, here we have obviously some details preserved and some details not preserved. This is the disadvantage of global threshold application. For us to be able to find all the available thresholds that we can have from scikit-image library, we'll be using a very interesting function. So in this next chunk, I would like to import from scikit-image filters a function which is called try all threshold. Now this will output multiple matplotlib figures, so to say, and from there we will see which algorithm works the best in the case of our image. So let's import RGB to gray as well, which I did above, but I just want to highlight it once again. So we now have our RGB to gray image here, cat grayscale. So basically, I will be applying my try all threshold function on that image. Now I will be using cat grayscale here. Our verbose will be set to false, and in the end I will show it. So this way we'll be able to find out which is the best algorithm. So you can see that this is original, this is ISO algorithm, this is Lee thresholding, minimum threshold, triangle, yen. I think for this image, we might have edited it as well before applying this effect, but you can see that two algorithms gave quite good results. In this case, it's yen algorithm, and the minimum preserved the eyes, and Lee algorithm also preserved some main um, contours of cat's face. So this is an example of thresholding. Um, in the case of thresholding, you need to test a little bit and adjust brightness, contrast, in order for you to obtain some beautiful results. So I hope this tutorial was helpful.